Hi guys, this is notes for section 4.4. I am going to go through some examples, and hopefully that will be enough for you to be able to get started. The first example that we're going to look at is this one right here. Let negative 3, 4 be a point on the terminal side of theta, and then from there we need to find the sine, cosine, and tangent of theta. So first thing we have to do is plot the point, which is right here, negative 3, 4. And once I get that point plotted, I'm going to draw an angle that starts at the origin and then goes through the point. This angle here is a very large angle. It is a quadrant 2 angle. So that means we're trying to find the sine, cosine, and tangent of this great big angle right here. The problem with that is it's not a right triangle. So we don't have opposite, hypotenuse, and adjacent. So that's why we then go to this next step where we make a reference angle. And again, remember, we make a reference angle by drawing down to the x-axis. Oops. So now we have this little reference angle here, and we can use it to find the trig functions for this larger angle. Now that we have this little right triangle here, I can put the sides in because I know that this side here was negative 3 and the y value was 4. And then using the Pythagorean theorem, we find that the third side, or the hypotenuse, is 5. Once we have this right triangle now, all of our trig functions are available. The sine is going to be the opposite over the hypotenuse, which is 4/5, and the cosine is going to be the adjacent over hypotenuse, or negative 3/5, and the tangent is the opposite over adjacent, or negative 4/3. Now you can use unit circle trig on this if you want to. You would have to then make this radius 1, so we would divide each of these sides by 5, and then our sine value would just be the y-coordinate, the cosine would be just the x-coordinate, and the tangent would be the y divided by the x. Okay, that's the first example. Now we're going on to the second one, and it's right here. Given that the tangent of this angle theta is negative 5/4 and the cosine of the angle is greater than 0, we need to find the sine and the secant of this angle. Well, the first thing we have to do is figure out where the angle is, and that's where this stuff right here comes in. We know the tangent of theta is negative, and I know tangent is negative in quadrant 2 and in quadrant 4. This right here tells me the cosine is positive. That's what greater than 0 is going to let you know, that the cosine is positive. And I know cosine is positive in quadrant 1 and in quadrant 4. So the quadrant that satisfies these conditions are going to be this quadrant here at quadrant 4, because that's where the tangent is negative and the cosine is positive. Okay, now that we know that our angle is a quadrant 4 angle, we need to draw it. So I'm going to just draw in some angle here in quadrant 4. And again, that is too big of an angle. The angle that we are looking at is this great big one here, which doesn't do us much good. So what we're going to need to do is draw ourselves a reference angle by drawing up to the x-axis, and now we have this small reference angle and a right triangle, so we can find trig functions. I'm going to now put our sides in. I know the tangent is opposite over adjacent, so I'm going to put 5 in for the opposite, or it's actually negative 5. I'm going to put 4 in for the adjacent, and using the Pythagorean theorem, I get the square root of 41 for the hypotenuse. Now that we have all of this in place, I can find all my trig functions. I know my sine is going to be negative 5 over root 41. Cosine is going to be positive 4 over root 41. We already know the tangent. The secant is going to be root 41 over 4. And the cosine is the cosecant is going to be square root of 41 over negative 5.